So, functional reactive. What does it mean? Huh? Good question. Huh? And then with core Java. Well, I want to explain a little bit what's my understanding about functional reactive with core Java. And we have a short view to 8, 9, 10, 11, and so on. Huh? The Java release cycles are speeding up. My name is Sven. I'm by myself coming from Germany, and there from this part that's called Bavaria in the south of Germany. And I'm working as developer advocate for Vaadin. Vaadin is a company from Finland, and they are building a web framework since quite a long time. And we are just moving from GWT to Polymer 3. And yeah, I'm coding by myself Java since 1996. And I'm mostly focusing on distributed backend systems. And now I'm working for a UI company, yeah, because I'm doing the part behind, say, thinking about all this stuff. I have done consulting worldwide and joined Vaadin 2017, so I'm quite a fresh member, and I'm an Oracle developer champion. Thank you, I'm invited here. And if you're thinking about what I'm saying and all the things, why I've done this decision or that decision, it comes from my background. So always have in mind that my background is mostly influenced by very old legacy systems, a huge amount of lines of code with a huge amount of different consultants that are jumping in, jumping out, and playing around with their code, and everybody has a new idea what's good and bad, and paradigms changing over the time. So if I remember what somebody told me during the 90s about object-oriented coding and what's best practice, and I'm thinking about what sometimes the same person is saying to me now, a few things are changing. So one thing is, in Java, we have an object-oriented style, and now we're talking about functional programming. Wow. Well, if you're thinking about, can you read the code? The last row, can you read the code? It's okay, no? Otherwise, jump here in front. Then I have a lot of code here, so you can use now the time to move forward, because later I'm going more in detail with the code. Okay, thinking about code and object-oriented and functional code style means that there must be a border between now it's functional. So if you're asking someone from the university what's functional, then he will have a very strong meaning about what's functional and what's not functional, and where's the border and what's right and what's wrong and all this stuff. And if you're working in an industrial environment, well, the border is not quite clear. So sometimes, if you have something like an optional, a holder for value, that you're not dealing with the value itself, and you have a method like is present, is this object-oriented style or is it functional style? It's a question, no? If present, and then I'm giving a functional, a lambda construct, is this lambda construct now functional? It's a question, no? And the same with throwing exceptions. So the definition to throw in an exception with a lambda supplier style thing. So is this now functional because I'm using different syntactical thing? Yes or no? It's a good question. Huh? And so on. If I'm using method references, it's the same. We have now with Java 8 a lot of new syntactical stuff, and it will be improved with Java 10, with var, for example, and with Java 11, JDK 11, we will get this var, if I'm informed right, for method signatures, not only for local variables, and so on. So the syntactical stuff is increasing, and if I'm switching my lambda construct to a new function something, to an implementation, on-the-fly implementation of an interface, is this now object-oriented because I'm using a different syntactical style? So I would say, it's my personal feeling, or it's my personal thinking about it, the border between object-oriented and functional coding in Java is not 100% clear. But we can, or I decided to say that I'm speaking about functional aspects to get rid of all the discussions, it's purely functional, yes or no, okay? So I think we can learn a lot about functional stuff, or we can use all this stuff, but have in mind Java is object-oriented, and we have to deal with both worlds. And sometimes, if you're mixing stuff up, it's better than being purely functional or purely object-oriented. There is something called functional interfaces we got with Java 8, and this is a functional interface. We have this marker, this add functional interface, and we have one method to implement. Everybody would say, yes, boring, old style. Yes, it's a functional interface. Do I need this annotation? No, it's only a hint for myself to say I mark it as a functional interface, and if I'm adding one more method signature, compile will break. That's all. Okay, so now I have a default implementation. It's a functional interface, yes. The definition says only one method you must implement, and all others are with an implementation, even if it is a default implementation. Okay, now it's a functional interface. Why I'm talking about this stuff? Yes, we need these functional interfaces, and all this stuff in terms of inheritance to design functional aspects in Java. Because with functional interface, I can use lambda expressions. Okay, we have a bigger team, and going to functional means that you're going to more generic things. To more generic, or going more to generic abstract way of describing something means that normally in the brain, the coder will start using more generic words. And this means that if you're dealing with your colleagues and talking about how to name a method or all this stuff, you will have quite fast, if you're going more towards the generic way, the same words and the same ways of describing things. Let's assume we have something like this. We have different interfaces, and only to remind what's going on, let's say we have an interface A, we have a static method do more, and we have one method do something with a default implementation. Nothing fancy. Okay. Now I'm adding an interface B, extending interface A, and saying, okay, I have a method do something with a default implementation. Okay, now the biggest question, what's a winning implementation? Who says implementation from interface A is a winning implementation? Okay, who says from interface B is a winning implementation? And now I have to ask a question from which one you are inheritance starting. Okay, but now I'm doing this, interface C, and I have a method called do something with the default implementation. Great, but not inside the inheritance of A and B. So this happens quite often if people start designing APIs and using generic words. It's only a question of time in a bigger team that something like this happens. And now I will do something like this. If you start pushing your code to more abstract things, you need a place to put your functions. We are talking a little bit later about. You need a place to put all this stuff there. And interface are the right place to do this. I will show you why and in which way. But then you start implementing interfaces. You're using this interface like traits. So you say, okay, I'm getting out of inheritance trees, and I change my way of thinking about it and do it like a composition with a flat inheritance tree. So implementing a bunch of interface instead of building a hierarchy of classes. Okay, now I have a class A. Is this a valid implementation? Yes, it is a valid implementation because for everything we have a default implementation provided. I don't have to do something. I only have to write class implements interface A and B. If it makes sense, it's something different. If I'm doing the same with class B and says I'm now implementing interface A and interface C, I have an overlap with method signatures because I have 2 times on the same inheritance level in default implementation for the same name and the same method signature do something. And now the compiler immediately would say, okay, break. You have to do something like this. You have to override, and you have to decide for the compiler what you want to do. There's no way around. Okay. Then only to remind again how to invoke methods. Sometimes people are starting implementing functions or static methods in interfaces, and they having in mind how to use this as a developer. So if you start designing APIs or functions or whatever always have a view from the point of a developer that has to use it. It makes no sense to write very fancy APIs if the developer who has to use it needs 10 days to understand what you want to do, and it's ugly for him to use it. So make it usable. So do some easy tests, like try to invoke a method. I saw quite often that people are pushing some static method to an interface and thought they could write my implementing class .do more to invoke the static method. It's not possible. Have it in mind. Okay, because you always have to go to the interface .do more to invoke the static method. You don't want to have it because then you force someone to understand the whole hierarchy. Yeah? Okay. Well, only to remind, this is inheritance tree, and invoking this method will give you exactly what you're expecting. So class A, the winning implementation, is the most specific implementation. It means is do something default implementation from interface B, and from class B, it's your own decision, and the interface A static method will do exactly this. Having in mind that with default implementation since Java 9, you can extract some parts of the default implementation. With Java 8, you have a huge default implementation. There was no way of being more structured inside this. With Java 9 and the following, you have the possibility to have private methods without the default keyword in interfaces. So you can structure your default implementation much more. It's only to write much more cleaner code. Huh? Okay, having in mind what's the optional. Optionals come with Java 8 and give you the possibility to wrap something around the value. And we have something like empty, off, or of nullable to create this thing. What we try to avoid is dealing with null. That's the main thing, how to use this optional of type T. This is good because in functional world, you don't want to deal with null. You want to have always a reference you can normally work on. You have since A, this is present and how to get this value. But the biggest problem in Java 8 is if you're getting something out and it's null, it will give an exception. So since Java 9, you have a .stream. And if there's no value present, you have an empty stream. So getting rid of the null pointer exception stuff inside an optional. But there are some things that are improving with Java 9. For example, you have the possibility to describe both ways. Yes, you have something. No, you don't have something with if present or else. This is much more functional style because now you can add something stateless to say do something with the value or do something else if there is no value present. For example, logging something or whatever. But you're not grabbing the value out of the optional to decide with if not null do something. So you can put the logic through the value itself here. Okay, so you can do all this stuff, but if you're analyzing a little bit more the optional, then you will see that there are some limitations. Some limitations in terms of, for example, if you start dealing with value, you have this value inside the optional, how to transform it. With the optional itself, it's possible to say, okay, I can map, I can transform this, and the input of this will be a function or method reference. Okay, now starting thinking about functions. Describe the function, and this is the input. Mostly in the documentation, you will see something like write some lambda style or some method references, but this is not enough. The same with JDK 10, we have the possibility to say or else throw, but having in mind that this optional will give you something, you have the problem that this optional itself, it's final. So if you want to extend the optional, it's not possible because the class itself is final. The main thing that is not nice is the optional itself is not symmetric. You can say if present, but you can't say if not present. If absent, if not present, or whatever. You always have to make a negative decision in front of. So it's not symmetric. This is not nice. The other thing is thinking about functional. Functional and reactive fits very good together. Functional and reactive, okay, but I have only blocking calls on optional, so I have to get it out and put it to something or to deal it by myself. Why not giving non-blocking calls to or the non-blocking interface to this optional? From my point of view, it's not functional enough. I will show why, and it's declared final, so you can't extend the optional in a classical way. You have to rewrite the whole stuff. We need something, and I call it result of type T. If you're designing something, then have in mind that you have a very easy transformation between going into the JDK class and going out of the JDK classes to make it as easy as possible to build drop-in replacements. Means in the same time that you have to fulfill the same interfaces, so grab all from optional and then start extending the stuff so that you can easily switch between this. And normally, if you're going to this, having in mind that you have a lot of reactive stuff inside the core JDK, so have it in mind and design your API for it. I will show you it's really easy. And always APIs, please create them symmetric. Don't have always a positive style. And don't forget, maybe I like the functional style. I really like this functional style, but my colleague, he hates it. Okay, what I'm doing? Pushing him to say, no, you have to use my API and this is the right world? No. Having in mind that you can design it in Java in a way that you can use it functional style, but you can use it optional style as well. Otherwise, your colleagues are not using your API or they don't like it or whatever, and this is always not good. Okay, so what we can do is to optional from optional is very easy. Then you are in the world of JDK and out of the world. Then doing the same. Success and failure. Have the positive way, have the negative way. Yeah, why? An optional with null is something special. Then define a successful result or a non-successful result. And then you can type it, because a non-successful result is more or less something with null as value, but with string as a message. Having in mind that exceptions coming later, you have to deal with the message that's coming out, the information, you have to transport it. Okay, so then symmetric, unsymmetric, or symmetric, symmetric, yes, and then if present or else, give single ways, and don't force someone to have both ways at the same time. So normally I see if or else, or so if present or else, and then if you have only something for the negative way, you have to deal with stupid non-implementation, so this nothing doing implementation. So having in mind that you say, okay, you can say only if absent or if present or both ways together. That's the only way that you handle things together. Okay, if you're doing this, we can start doing it in a more asynchronous way and only extend the word here. And the thing that I will show you is that the if present or else is only a function, and then if present or else asynchronously could be a function that will be executed in a completely future. How to deal with complete future is in the end of the session. But then you have the possibility to write blocking calls and non-blocking calls. You can present them and always using the same naming schema. So same naming with asynchronously or whatever. Thinking about values, mapping stuff. If you have an optional, and you have a wrapper around, this is the first thing to say, okay, I'm dealing with values and holding them and transforming them. But now I have a different object. Now I have an optional here and an optional there. And now how to deal with them? Mostly, you will be forced from the APIs to get the value out of the first one, getting out of the second one, grabbing a function and putting both values inside. How stupid is this? It makes no sense, because then you're breaking the semantic style of this. So having in mind that you do something like then combine. Combine means I have a value in my optional, and then I'm combining with a value from outside, and then you have to provide a function, a transformation. A function is nothing else as a transformation. Here, it's a by function. I have the internal value if present, and the external provided value, and now I'm transforming, and I will stay inside my result or inside my optional. I'm not grabbing it out and wrapping it again. Okay. This, again, could be asynchronously, easily, only wrapping it inside a completely future. And having in mind that mostly if you're reading the stuff in the internet, they will show you how to combine with values. But a value, what's a value? A value is not an integer. A value is not a car or whatever. A value could be an instance of a function. Okay, now, having in mind that combining stuff could be a value plus a function and a by function that is using a value and a function to do something. Functions or instances of functions are a value as well. If you have this started, we can go now to exceptions. In a functional world, you would say, okay, you have to deal with all this stuff, but get rid of exceptions. Having in mind that mostly, if you're reading this documentation, you will have something like this, for example, inside a stream or whatever, an integer parser int, and then someone is grabbing values from an input that the user is providing, and it could go wrong. So you start with try catch. With a stream of value 1, 2, 3, something 4, map to int. Okay, I can parse this int, how to deal with this exception. Going through the most books, it will lead you to this solution. And I think this is ugly. Why? A stream is a queue of a bunch of transformations. Okay. And if you have always this exception thing inside, you're writing a lot of boilerplate code. Try something, and then catch, and the biggest problem is the return type. Because then I have to decide which value is a value with a special meaning. Even this is not right. Huh? So I have to get rid of this. Going to functional means extract as much as possible codes that you're writing again and again. Okay. The first solution is that you say, okay, I want to get rid of this 0. So I'm wrapping the stuff inside an optional. I would say, okay, if everything is right, integer will be wrapped in an optional. And if there's an exception, I will give you an empty optional. Okay, this is good. But after this, you have to wrap it out. Or you have to use something like a flat map to unpack the stuff. Otherwise, you have something like an optional from optional from optional, and so on. With Java9, you have this if present and get out. You can do with a flat map stream, but both is not nice. Okay, what can we do? Having in mind that this try catch block is quite easy to describe. It's always the same syntactical stuff. Let's say I create a checked function, type with A and B, and I have a method with apply with exception. Inside this definition of this method, I have the thrown exception. Good. Because a normal function don't have this one, so I have to write this try catch. What I'm doing here is quite easily, if I'm writing this is a checked exception, I can extract this try catch block to a function, so I'm extending function, and I'm wrapping the types, the second type, the output type, into a result dynamically. It will lead you to something like this. The new checked exception is a functional interface with one method to implement. Yes, this apply with exception. And the default implementation is now for apply. So inside apply, I will say invoke apply with exception. If something will happen, wrap it in a failure. Otherwise, wrap it in successful result. And now I can say the integer parser int, the method handle, is something like a checked function. And it's, by inheritance, the same like a function from string to result of int. So what I've done now is I extracted the try-catch block, and I typed it completely in an easy way, because the user only have to say from string to int. I don't force you to write this wrapping in something. Okay? The implementation itself is quite easy, as I told you. Now the default implementation is apply. There I'm doing all this generic stuff, this try catch, and I have only to implement the apply with exception. That's it. If I have done this, the next step is quite easy. A checked consumer is nothing else as a checked function from T to void. Done. The next is I have a checked executor. This is a function from void to result of void. It's the same. It's all defined. A checked supplier is nothing else as a supplier of result of type T. Same. And so on. Functions and basics. Function itself is something from int to int doing something. It means I have an input, it has a type and value, and it will be transformed to another type and another value. That's all. So This is quite easy. I'm using int here. So mostly I see that people starting writing it like this. So function A, function B, function C, and then they invoking all these functions, and with this they're invoking the next function. Okay, don't do this. Then they start chaining functions, but in a way like methods that you learned like in your object-oriented way. So apply, 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 apply. But you can do it with compose, for example. Compose is something that I would say, okay, I describe now, I have a function A and a function B, and I can chain them in a way that I have a function, a result function, and this I can use. I don't have to chain all this stuff by myself. But with compose, we have some challenges. If you want to compose or chain functions here, you have to use syntactical stuff with compose that use writing this typing explicitly. What's gray, the next two lines, compose without this function into int, is not possible because the type interference in Java is not possible to define the type, so to find out what's the right type. Because compose is do something from a type that will give an int that is my input int type, and so on. And he's not, the type interference is not able to understand what's before myself. So this is typing ahead is not really easy for him, so you have to write it. Then as example, you can start writing a higher compose, and it will lead you to stuff like this. Don't try it. You can do it as an exercise, but never use this. And the main thing is that it will lead to definitions like this. It's unusable. And you're not winning something, because if you're doing something like this, you have to define the types in another way. Instead of writing it in the invocation, you have to define it now in front of the invocation. So you're not winning something, and it's a very complex way. So compose is maybe a little bit difficult to use. Let's say, do it another way. Say and then, so don't define before you, build the chain behind you. And this is much more easier because then the type inference is quite easily to understand what type you're using. And then you can say, okay, and then, and then, and then, no additional information must be provided by you. Only have in mind that must be a little bit easier to, or a semantic equal thing you are building. Now the biggest question is here, if I have now this function A and B, this is completely typed because I'm writing int and int. This is not generic. So how to write a function with type A and B and get an instance out of it? And this we need. So one way that I could recommend is start implementing inside an interface static methods that will create on the fly the instance of a function for you. Because then you can say, here it's fully typed, int to int, int to int, and so on. But later you can say, create me a function of type A to B. And then you can start using generics much more easier. Yes, the same is with applying all this stuff. Currying. Currying is one thing. If you have this add and add and add, what we use as an example here, the next thing would be how to make this generic. So try to find something that you get rid of all the static things you're defining and make it more generic. I think we go here to a practical example to show what's going on. Having a list here with some names. And someone is writing this, stream, filter something, and print it out, and writing this one. The only difference between both implementations are this single letter, I and J. How to extract it now? How to extract the boring part that's written 2 times. It makes that first you can say, okay, as a consumer, this system.println I'm extracting like a consumer with a method reference, okay. I'm extracting the value. This is a way normally developers are going through. They're selecting something, say extract method or something like this. And the IDE is more or less trained to do it in an optional object-oriented way. And then you have this predicate that you can use with these variables you're defining. And then you can write something like this, a stream, filter, predicate 1 for each something. And then you start with the second one, and it turned out that you're not winning anything. Why? Because this one is final. So we have to get rid of all this stuff you're defining on the fly because you must define it final. So having in mind, this one I want to have dynamic. Okay, and this is a place where I want to use it. This means thinking not in there is a value that is used in a function, thinking about, for example, there is a function that will create from this input value the instance of a predicate I want to use. Now we start creating not a value, but a function itself. From a value, creating an instance of a function. What's here? This is the input string. And now I'm creating here the predicate that is using the string. Now I can create the predicate on the fly itself. It means I'm going here and says, okay, name, stream, filter, and now I'm creating the predicate based on this dynamic value. Now I'm winning something, because the only difference is now this thing that is dynamically extracted. And this is mostly the first barrier if you're object-oriented trained to get this second step of make it more abstract. Get rid of the value itself and thinking a value is nothing as an input for a function. So describe a function from to whatever I need. The same is with currying. I only want to give a small overview. The slides will be available, and then you can reread all this stuff. But dealing with functions normally means that you have one input, one output value, and this is what you're reading in functional style documentation. But then you have this by function. We need some by function to combine legacy code with functions. Yeah, because I have methods with more than one input param. But how to deal with this? One thing is the name currying. Currying means that I'm breaking the by function with two input values to one input value to a function that will create me the next step that is a function that has the first value inside, getting the next value, and providing the same output. That's a very easy way to describe currying. There's a little bit more, but you can do it in a very generic way. It's only to see it once and then using it. I don't do it every day. But, okay, functions are transforming from A to B means I have a function that will transform a by function to a curried function. And if I have it in this way, by function to curried, I can do it in a generic way, curried function to by function. We need it, for example, for memoizing, so partially caching on different things. There is an implementation. The main thing I only want to show here is that you're only chaining. You say first input value, apply second input value, and then you hold both values, and then you're applying it on the original by function. That's the only thing I want to show here. It will take some time to write this code once by yourself to understand it clearly. But the main thing is that's a very generic thing. You don't need types. You can really work with generics here. So the currying and the transformation of functions is something that can be completely generic described in Java. And then you can go both ways, to currying, forward, and backward. The main thing here is that I make it short here with this currying stuff. You can do it in both ways. You can do it in a synchronous way. So if you can do it for by function, you have the solution to do it for try function. Go, create your try function, and then do the same stuff only with one more layer in between. That's all. So thinking about design pattern in functions, only check for value-to-value transformation. A value could be a function itself. And then maybe for by function too. And then mostly you have all solutions for n functions. Okay? And then it's only chaining. Memoizing is a quite easy but powerful thing. Memoizing, if you're talking about functional, and we are talking about an integer. If I say, if I invoke this function with integer 1, I will get 2. This is easy. I'm invoking twice, and 2 times I will get 2. This is easy. But now my function will create from input A instance of a car. I'm invoking the function the second time. Now I'm getting the same car or a different instance with the same values. So if it is really, what's the same? Normally in a functional world, I would say it must be the same instance, the same identity, exactly the same reference. to have this in Java, and I can show you what cool stuff you can do with this, is called memoizing. So remember that you calculated once this value. To implement this, you can use this method from a concurrent hash map, compute if absent. Input value, check if the value is there, then grab the already calculated. If not, use the function I will provide to calculate the value stored and give always the same reference back. Memoizing is done. This can be done with by function, try function, and so on, because it's a very, very straightforward caching per dimension. And then you need for this to implement this currying. Lack of time a little bit, so I'm jumping here over this. But the main thing is, memoizing could be a multi-dimensional thing. You're caching per dimension. The main thing is only having in mind you're providing a function and a value inside a concurrent hash map. That's it. What are you doing with this? Having in mind that you have a legacy clause, something that you can't change. You don't have the source code or whatever. It's not allowed to change the code and so on. And the computation of this method is not fast enough. You can start with partially caching. Means you have some new API, do some new stuff, and you want to write all this functional stuff. And now you have to combine your legacy stuff with your functional stuff. Oh, how to do this? What you can do is the following. You have an instance of your legacy clause here, and then you would say, okay, please, from this instance, double point, name of method, give me the method reference from exactly this instance. And this is nothing else as a by function. So checking here, this one, there is no typecast, nothing. Okay, now I have the possibility to have a legacy instance, grabbing the method reference out, and dealing now with this like a by function or try function. Now I understand, okay, I need a by function, try function, whatever function, to have the right method reference for this old style, a lot of input values method definitions. And now I start currying this stuff, now I start transforming this. Now I'm a functional world without changing code, okay? I can immediately start working with this stuff. And here it means, with this here, I have my legacy implementation, I'm grabbing the method reference, and then I start memoizing. It means this method instance, this instance from this my legacy class thing is now caching. The invocation of do work is now caching. If I'm calling it twice, it will using the hash map that are provided around this. But the original instance not change, so I can give the original instance back to the next invocation that is maybe expecting the legacy implementation, not a caching implementation, okay? So now I can switch between both worlds without changing code, recompiling and all this stuff. This is, you can use it for something, it's quite nice, I think. The next thing to do stuff more functional is dealing with decisions. Decision means I have now different ways of doing something. In an optional way, I have if present or not. You have two ways, but how often you have more than two ways? What can you do? In Java, you can say a switch. Okay, it will be extended with Java 10 and 11, but switch. And you have this if then else, this typical code style that will break to one side of your monitor. Or this a little bit more functional style here, but then you must provide a value. All of these styles are more or less, yeah, one provides A, one provides B, but I don't like all of them. What a surprise, huh? Mostly what you need is something, you had something that will give you true or false. And if something is true, you have something that must happen. And this is a pair. This Boolean or this expression to say yes or no to this thing that should happen. What I need here is I have a pair, so always two things. And the first is a supply of Boolean. Inside the supply, I can do whatever. I can check inside the database or checking in user interface or whatever and say, yes, it's the right case to do something, or no. I only expecting yes or no. Whatever will lead you to this decision. And then I have a supplier, what to do, wrapped in a result. But as a supplier, so that it's not executed during the time you're checking the Booleans, only if it is true, then you're activating the calculation. Okay, and this means now I have not this if then else stuff. Now I have a linear list of decisions. And it could be easily extended. Only one line more, check this one, do this. And this is mostly very easy to deal. And there's one default decision, is nothing will say yes. There's one default thing that will be activated. It could be a success, it could be a failure, whatever you want to have. Checking how this will look like in code. Fully type, without static imports, it will look like this. You have cases and say, okay, if it is this one, the result is whatever, or the next one, and the default, the first defined, will be a true or false or whatever. To make it a little bit more nicer, everything is inside the result. It means you immediately, after the decision, can work with if present or map or combine and all this stuff. And with static imports, it will look a little bit more compact, and that's it. You say, now I start with decisions. This is my default thing I want to do, and then all the cases you want to check. That's it. And then you're fully inside your wrapped environment. You can say map, transform, combine, asynchronously, and so on. If you have one more case, add one line. That's it. The same with streams. With streams, I don't want to go to the Streams API. Streams API is huge, but a stream is active after creation, and mostly you're reading documentation and they say stream of doing something, and then you have a fully typed stream. And then you're defining the stream, and one page later you're describing the next stream, and it's more or less the same. No, don't do it like this. I want to define a stream without being active. I want to create the stream maybe interactively. So if a user say yes or no, the stream will be concatenated or created and all this stuff. And what I need is quite easy. I need a function from some input value to an instance of a stream. Now I have a function, and only if I say, no, the value is present, then the stream will be created. And if this is a function, I can chain functions easily. Oh no, this is, I don't want to go through this. The same with observer. This observer is more or less now the next thing we want to do. If I now have these functions and I'm thinking about a function could be from a value to a value, or a value to an instance of a function, or a function to a function, or two functions to a function. So thinking about values are not only scalar values, it could be a function itself. You can go to this asynchronously, I think. It's a complete future. I only want to show here the power of complete future that you have in every JDK without using different libraries, Eric's Java and all this stuff. You can do a lot of stuff with this. Complete future is something like a fiber. It's less than a thread. It's some piece of work that will be pushed to a pool of threads, and then you have this completion stages, and with this you can deal. Why this is nice? I can show it to you in only a few slides. You can say, to create a complete future, you only say, for example, I have an executor service, a dedicated resource where you want to push the work through. And then you say, I have a supplier for value or whatever, and then you say, completely future supply asynchronously. This task or this function in this pool. Perfect. And then it's a non-blocking call. Now it can do something. Okay, now I have a complete future. If I want to join and say, okay, wait until the value is there, if you really want to wait until it's there, and then don't forget to shut down the pool, otherwise your hello world is not stopping. It means if you want to chain stuff, create a complete future, supply asynchronously with this in this pool, and then accept asynchronously the next step. If we created a bunch of functions, we can now chain the functions, but non-blocking. And we can say, do it in this pool or that pool. The main thing here is how to deal with a more complex thing. So if you have different values from different resources, they are not available immediately, for example, from the network or from the file system or whatever, and you need both, and you have to wait, and then there's operation, and then this result will be input for something, but you are waiting for the next somewhere coming value to calculate something. If you want to build something like this with threads, you're building a huge thing, and it's not easy to write. With complete future, we are quite easily done. We say, okay, I created my complete future for all input values, and now waiting until they are there. You don't have to wait because it's non-blocking, and then you can say, then combine asynchronously. Means I have here something I'm waiting for. And if this is here, wait until this value is here. Now I have two values, and now I'm adding my by function. So transforming stuff means transform it first to a more functional way. And if you have abstracted it stateless to functions, you can start making it reactive in a very easy way using completely futures. Because now you're changing the functions inside completely futures. That's it. And this is completely asynchronously if you want. And you can decide, do it in this pool or that pool. Even this is easy. You can write it a little bit easier if you can say, OK, now I'm putting functions inside on the fly or whatever. The main thing here is that if you're checking here the difference, you need only a few lines of code for such a complex task. Writing this with threads is much more work than writing this with complete future. The main thing is that complete future working inside your JVM. If you're thinking a little bit more, checking out for FN project. It's a really nice open source project. And then you can grab all this function, all the stuff you have done with complete future and put it to functions that are running in a Docker cluster. Perfect. And then you can scale, not only in your only thing. The main thing is to define all this stuff is quite, it's a huge thing. A complete future, again, is starting immediately if you define it. OK, we want to get rid of it. We want to create maybe a chain of complete futures interactively. And what we need, what is surprise a function from T to completely future. That's it. So now everything fits together. We can create functions, we can create streams and complete futures. And to make this a little bit easier, don't forget that what you learned in your object-oriented world. Have in mind that you have functions, for example, these three functions, and you want to combine them in this completely future world, then you would say complete future, compose asynchronously, and so on. What we are doing now is quite easily. You know the builder pattern, no? Builder pattern is a pure object-oriented pattern. Don't forget them, use them. Because if you're using them, you can go to stuff like this. Writing a builder pattern for a completely future tree. And it will lead you to something that you say, I have my complete future queue. I'm defining the first node, my root node, with step A, first function. Then combine it, and give me as results a function I want to invoke. Nothing is started until now. Everything is defined. You're using functions to define what's in your queue. And then, if it is the right time, you will say, the completely future apply. Now I'm starting this stuff. The implementation, if you're checking this, is much less work than the manual version on top. You can use completely the functions you're creating before. JUnit tests are only running on the functions because trust the completely future implementation. You don't have to test if concurrency is working well. You only have to test if logic is right. And the implementation is only a few lines of code. Means you have you're holding an instance of a function from T to completely future, yes. You have the static method that will start with an initial state. And with every second you're combining, you're only creating the next step of the function holding this instance. If it is time to say build, here I called it result function, grabs the instance and provide it. It's a builder pattern. So what I want to say here is that don't forget what you learned in the object-oriented world. You can do all this stuff. It's quite nice. You can reuse it, but try to extract state as much as possible. So to say, OK, every state is outside. Thinking about functions not only as a fully typed instance of a function that you're writing down. Create a function that will create the instance of a function. Then you are much more generic. Then you can combine all the stuff. The right place to put all this are interfaces, static methods. They could be written in a very generic way with generics, and then you can combine the invocation of these methods. OK. With var, we have some stuff with JDK10 that we have this typing out. The more interesting thing is coming with JDK11 that the var itself is not only var mylist new array list. Then you can use it not for local variables, but if I'm informed right, you can use it for method signatures as well. The only thing having in mind is checking out var mylist new array list. You don't have a list. You have an array list after this. So I have no idea how to reduce it to interfaces again. If you want to have all this stuff that I showed here on GitHub, this is a repository where you can find the whole code. And otherwise, the main thing is you can ask me for this stuff. If you want to extend this for serverless stuff, use all these functions and push them in functions inside FN project. This is available on GitHub as well. And then you can scale it out of your JVM. Well, this is a lot of stuff. I'm not done, I know. And I only want to give some examples or ideas what you can read now, what you can go through, having in mind that there are a few things or a lot of things that you have to reread and try out by yourself. But feel free to ask me. Contact me via LinkedIn, Twitter, or whatever. Search for my name. You will find me, I think, in every social network. And then try it out. Go to GitHub and do it by yourself. It's a really most important thing to do it by yourself. The implementations I showed you is only a few lines of code. It's only a few kilobyte code. There's no additional dependency you need for your project, but you can get rid in quite often of Eric's Java, Mockito, and all this stuff. Yeah? So check what's inside the core JDK. There's so powerful stuff inside, but use it. For most use cases, it's really enough. Okay, thank you very much. It's time to hurry home. And, well, it was nice in Singapore. Okay, recording is off, huh? Great. So, feel free to ask me. Otherwise, I'm in a meetup right now. I'm talking about, I think, mutation testing. If someone is interested in what's mutation testing, I have to follow me. Okay.